All right, last few. So we've got number 18. So a population of 430 bacteria is introduced into a culture. Hang on, I can't find my pencil. All right, is introduced into a culture, and it grows in number according to the equation below. T is measured in hours. Find the rate at which the population is growing. So find the rate at this exact moment in time. So that effectively is telling you to take a derivative. Round your answer to 2 decimal places. So first of all, I need to take a derivative. So that's what this says. Take a derivative evaluated at 2. So I'm going to go ahead and distribute this 430. Okay. So I've got a 430 plus 430 doubled is 860. T over T squared plus 20. They have 20 plus T squared. I just put it in descending order. So now what's the derivative? This thing's derivative is 0. And on this one, I'm going to have to use quotient rule. So I'm going to go ahead and come over here to do that. Ooh, almost dropped it. All right, so I've got 860t over t squared plus 20. So my derivative, I'm going to have to use quotient rule because my bigger picture is variables over variables. So I've got the bottom times the derivative of the top, which is 860, minus the top, which is 860t, times the derivative of the bottom, which is 2t, all over the bottom squared. So I got t squared plus 20 squared. All right, that's my derivative. And this is what I was yapping about a few videos ago. Instead of me cleaning this up now, I might as well just go ahead and shove in a 2, and it'll kind of clean itself up along the way. I don't know if that makes sense to you, but to me it's easier to substitute now. So a t squared of t is 2 is going to be 4 plus 20 is 24 times 860. And then 860 times 2 times 2 times 2 is 860 times 8. Okay. All over 2 squared is 4 plus 20 is 24 squared. And when I round this to 2 decimal places, what I will get is going to be 24 times 860 minus 8 times 860. And now, side note, this is real life factoring. Both of these have an 860, so you could have factored that out and done 24 minus 8, which is 16, and done 860 times 16. Anyway, fun fact. All right, so I have this, and then I'm going to divide that by 24 squared. So 24 squared is, and I get 23.88888888. So I get 23 point, how many decimal places? 2 decimal places. 89. So we have partial bacteria. All right. So I've got basically 23.89 bacteria per hour at that precise moment in time. Okay. All right. So number 19 says I need to find, hang on, I don't know how many we have. All right. Find the second derivative. So it sounds scary, but it's not. So first of all, notice that I've got a double tick mark. Okay. And so that's why it's not F with a square and then X, because we don't want you to get confused. So it's a double tick mark. And so I'm going to take a first derivative, which is 4x to the third plus 30x squared minus 18x minus 4. And then I'm just going to do it again. Okay, so this thing's derivative is 12x squared plus 60x minus 18. That's your second derivative. So if you put this in context of projectiles, this would be your position function, this would be your velocity function, and this would be acceleration. Okay? All right, so find the second derivative of the function. I've got x times the sine of x. So I know I've got variables times variables as my bigger picture, so I'm going to have to use product rule. So I've got the first times the derivative of the second plus the second times the derivative of the first, which is 1. Okay, that's your first derivative. Now I've got to take a second derivative. So I have got this thing times this thing, so variables times variables. I'm going to have to use product rule on this part, but not this part. So I've got first times the derivative of the second, which is negative sine, plus the second times the derivative of the first, which is 1. And then the derivative of sine is cosine. And so you could clean this up because your second derivative is done now. I've got a cosine plus another cosine. Means I've got two cosines. Okay? All right. This says find the given higher order derivative. And you're given 2 tick marks. And I need 3 tick marks. So if I'm at a second derivative and I need a third derivative, how many derivatives do I need to take? I just need to take 1. Okay? So I'm going to rewrite. So I've got 4 minus 6x to the negative 1. So I've done algebra. I've just rewritten it so it's friendly. The derivative of 4 is 0. And then drop your exponent out front. Drop your exponent by 1. And that's your third derivative. Okay? Because you started at the second, so now you're at the third. And you're done. All right, so for 22, what we have is essentially the same thing that we had on this graph a while ago. It's just that they pulled the information for us already. So I am told that f of x equals g of x times h of x. So I'm told that f is a product. Okay? I'm told that g of 5, which is a value, is negative 4. The derivative of g at 5 is negative 1. And then the value of h of 5 is negative 6, and the derivative of h of 5 is negative 9. So I'm just going to clean it up a little bit. I have f equals g times h. So my derivative at 5 is going to be the first times the derivative of the second plus the second times the derivative of the first. So I need to know what g of 5 is. G of 5 is negative 4. Okay? What is h prime of 5? Or what's the slope of h at 5? So h prime of 5 is negative 9. So I got a negative 9. What is h of 5? What is the value of h at 5? It's negative 6. And then what is g prime of 5? Or what's the slope of g at 5? It's negative 1. So I've got f prime of 5. Sorry. It's not negative. All right. Of 5 is. So again, value, slope, value, slope. And when I clean this up, I get a 36. And then I get a plus 6. So I end up with a 42. So f prime of 5 is 42. All right. We have the velocity of an automobile starting from rest is given by the equation below. So you are given a velocity function. So basically, somebody had a position function, which is s of t, and they've already taken a derivative and cleaned it up, and they got you this far. Okay? V is measured in feet per second, and t is time in seconds. So round my answer to 3 decimal places. Find the acceleration at 5, 10, and 20. Okay, so I can use my calculator if I want to, or if it's easy enough, I'll just do it in my head. But bottom line is to get from your velocity function. So I'm just going to write this out again. I've got a position function. The derivative of a position function is the velocity function. And the second derivative of a position function is the first derivative of velocity, which ends up giving you acceleration. Okay, so this one, take a derivative, take a derivative. So I'm right here. I've been given velocity. I just need to take a single derivative to get acceleration. So I notice that I've got variables over variables. So what I have is quotient rule. So I've got the bottom times the derivative of the top minus the top times the derivative of the bottom, which is just a 4, all over the bottom squared. So 4t plus 15 squared. And now when I clean this up a little bit, or actually you really don't have to, because we can put it in our y equals and go from there. So I have alpha, y equals, I've got a 4x plus 15 times 115 minus 115x times 4. And then that's going to be over 4x plus 15 squared. So I'm just slapping it in my y equals. And then when I do this, I need to evaluate it at 5, 10, and 20. So 5, 10, and then 20. Okay, so since I entered it in a fraction form in my y equals, it's spitting out fractions here. It says to round it to 3 decimal places. So it should take it because it's an exact answer. But if it doesn't, just do 69 divided by 49 on your home screen, etc. All right, so last one for this section is we have determined whether the given statement is true or false. So I need you to be able to see this. All right, so do you see this funny, hang on, sorry. All right, do you see that this says d to the 7th y and then dx7? First of all, you need to know that this version is a little bit, we don't like it, okay, because it implies something. But let me tell you, hang on, where am I? Here's what we're going to do. I'm going to show you something basic, and then we're going to go from there. If I tell you that my first derivative, or my original function is going to be x squared, okay, can I take a derivative? Okay, so I've got a first derivative that gives me 2x, okay. Can I take another derivative? So my next derivative is 2. Can I take another derivative? So I've got a third derivative, and it's 0. Can I take another derivative? No, because it's just 0, so it's meaningless after that. All right, so this is going to come into play. This notation is going to come into play very, very much in Cal 2. But what you need to know is this. First of all, if we are dealing with y's and x's, what I could do with this is I could rewrite this and I could say my third derivative in terms of y will reflect dx cubed, okay? And that's not how you read it. It's just the third derivative of dy dx, but it's more involved than that when you get into Cal 2. But notice I put parentheses around this, okay? Without parentheses, what it looks like is dx cubed. So it looks like the derivative of x cubed. And so our textbook has not caught up with that yet, but it is more proper to say the cube of the derivative of x. Otherwise, this says the derivative of x cubed, okay? So this is more proper, but this is what it says. Now go back up here. I had a second degree polynomial. How many derivatives was I allowed to take? 3, okay? Second degree, I had 3 derivatives. So give me some conjectures here. If I have a 4th degree, how many derivatives will you make? I bet I'll make 5. Okay, so you'll be able to take 1 additional derivative than the degree of your polynomial. So what does this say? This says, if y equals, and I got x plus 1, x plus 2, x plus 3, x plus 4, x plus 5, x plus 6, then the 7th derivative will equal 0. I need to know if that's true or false. All right, so here's the question. If I were to multiply this whole thing out, what would the order, what would the degree of my polynomial be? I've got an x times an x times an x. I've got 6 x's being multiplied together. So by the time all this is said and done, I've got an x to the 6 with a whole lot of terms after it. So what did we just decide? By the time, if I start with an x to the 6th, will I be able to drop this down and my 7th derivative equals 0? Yes, I can. So this is true. Okay? All this means is that if you have a polynomial of degree n, then you can take n plus 1 derivatives. Okay? And that is it. So now you are ready for the next section. Oh, I should warn you, I started, all of these are out of order. And so the way I organized the next few, there's some glitches, but I figured out why there were glitches, so they got fixed. So don't panic if some of it cuts out a little bit. It only happens a couple of times, and then I figured out what I was doing wrong. And that will start on the next section. All right, goodbye.